Good to go. Michael Wickerson here at Wickerson Studios, continuing with this first tier of learning Rhino from Grasshopper. And as I work through all of the curve commands, if you've followed the last two videos, we've gone through the point objects and we've gone down all the way to, I think, mark foci. So we've found a way to go in with those functions and bring them into Rhino through single point, multiple points, curve closest point, um, marking the start and end of curves, and marking the foci of an ellipse. And what I wanted to do today was I wanted to jump over and not only have these geometries at play, which were being fabricated by this script, and you can see that you've got some nice finesse to control that. But then what would you do if you had a tool like this, just playing with points and curves? Well, if I keep it kind of around the 0 mark and keep it pretty boring, I can take that information and go over here and start pulling out different geometries like here that are actually attractor points. These points are dictated by the distance of the sphere to the lines, and then the foci actually play a role in it. But what I've done is I've gotten into a bit of a sandbox over here, which is a geometry that produces what appears to be a fairly complex script, but I just wanted to go over it because it's got some really nice control. And even though it has parameters of its own, this is what I'm trying to do with these basic scripts, is put them to an algorithm that's fairly interesting. And the highlights tonight are going to be two things: the application of curve closest points, and then also the idea of remapping with bounds in a domain. That's one of the first things, or short algorithms, everybody should learn, I think, possibly for scaling information and making their scripts run. And then I do a kind of nice normal offset to normal from a surface, a little bit of moving, a few more curves, and then the piping through those curves. So the geometry here goes all the way back to the first part, way back into the script when we contemplate how many of those pieces we want in that system, and also the rotation around negative pi through to positive pi. And you can see down in the center you get this flipping which occurs, but you still end up with this kind of nice geometry that keeps trying to wander and get away from itself. And it's highly controllable when you start rethinking your domains as to where you want to go in the XYZ. So you have a lot of finesse and a lot of control to this tool, and it even has to do with that initial point, even though Z doesn't affect it. I don't know if this control point was actually pulled into it, and that's right, it wasn't, because we're actually dealing with the multiple points. So let's go back a second to where we were. We basically had pulled out a surface, and from that surface we pulled out points that were being attracted to that, and then there's a few other geometries. But what is needed for our playground script? And I'm going to walk us through, and we're going to build this one. It does need a few parameters in and of itself. And what I'm going to do is take off this so we can actually reconsider this entire algorithm right here as to what that really is and how we build it. And I'll try and make some sense of it. First things first, you're going to want to grab that surface. And even though in pen and ink it shows kind of the horizon line, so when you're underneath the horizon it doesn't get split, but when you're above it tries to show you what's not there. And that surface has been generated from those curves which came out of these lines, which we didn't draw in this direction. We actually drew from this direction and put it through a nice loft. So that surface is something to start with, and it's container of a surface, which is what you'll need. And those surface containers can be grabbed right here, over here. Grab yourself a surface and put it in. And that's the way you're going to start. The other things you need is you need the focal points, this one and this one, which go back, and a curve, each of those initial curves. Now we follow back these three items, and they'll highlight. You can see the curves going all the way back to that algorithm where we sat and produced the curves here. So going back to these curves right here and using those. So those have to be drawn out and brought all the way over to these curves. And those will be the curve closest point, but the two foci are actually these 2 points. And if you think about the data visualization we did before, those 2 data visualizations were these points here. And I'm just looking for the center on those. I'm looking for these 2 items which are tucked in the center of these 2. So that's about the only geometry I need to borrow to really make this algorithm run. And then the rest of it, these 2 focal points, these lines, and that surface. And what could we do with it? So what I'm going to do is walk us through from the start to the finish. I'm going to move down these parameters. I'm going to take this, and what I'm also going to do is, so it's not confusing, I'm going to take all of our first part of our geometries, which was all this wonderful stuff, and turn preview off. And then I'm going to have all this geometry, as we click it, it will come up. And you can kind of think about that. So let's go back to what we had. We have our surface, we have our point, 2 focal points, and we have our lines. And there they are. Nice to start. And the first thing I'm going to do is I'm going to take those points, those focal points, and find out the curve closest point to those lines. And that's how they're generated right there. We don't need a bigger visualization, but that's a nice use of curve closest point. And those are, of course, parametrically controlled by everything that was driving those curves and those points. I flatten that tree because whenever I flatten a tree, I'm able to use a little bit of dispatch. And dispatch is something that will take a flattened list, which I did here, so it's coming in, and it will take all of those items and it will sort half the points over here and half the points over here. So going back to both points, or going back to actually those, you've got this section and you've got this section. And you can see a line between them is just something I did to build a certain visualization. I don't think I do anything with that line after, but you're getting the sense of point and point containers and line in between. And that's about it. And you enter another realm of a very nice script right here called remapping. And I'm going to do it twice. I'm going to do it on the bottom. I'm going to do it on the top points and the bottom points. And what I'm going to do is I'm going to take those points and I'm literally going to get them down into numbers now. The x, the y, and the z attributes of those points. So we could keep in mind that they are here, but these are the points that I'm actually trying to find out. And in doing so, I do a nice little thing here. Keep in mind I'm just moving my surface over as I need it. So I'm still keeping this surface over here so I can keep a sense of where that is as those lines are on there. And what I do is I remap. Now remap's a very interesting tool. It is a node that's in your math nodes. You pull it out from up here in your math. It's one of the first ones in the first sections, remap numbers. You need a bounds, which will go from the x components from the lowest number to the highest number. And those bounds are right here. If we take a look, they're going to go from 0 to 1.318782. And the y component is also going to have a bounds that's going to go from -5 to 5.604075. Now those numbers are not easy to kind of figure out, so what I've done was built a domain that can apply to both of them. The default is 0 to 1, so you will need a remap, a bounds, and you'll need a target domain. So I'm taking these numbers that range from -5 to 5 basically, and these numbers from 0 to 1.318, and I'm mapping them into numbers that will then go from 0 to 1 as to where they are relative to one another. And then I can rebuild the point I took apart by those xy coordinates and think about that initial surface as a reparameterized surface. Clicking in here, reparameterized, which goes from 0 to 1 in the u and v directions. And I can map as a point, instead of using on this surface a node like the evaluate surface. And I'm not going to get into the details of building this from scratch. And as long as that's reparameterized, I could have put on what most people do, an input of a multi-dimensional slider, one of the most common components as well. And I can go in there and grab my surface and have a point that flows along that surface and will produce a plane while I do it. And that's it. That's why I've mapped those numbers. So these numbers that were much higher coming out of the bounds of those initial points in the x and y coordinate, I've rebuilt my points to map them between 0 and 1. So I end up with a wonderful system of planes. And this is another good reason to go to display. Plane size, I'd say 2 is enough. There's our little planes that are actually mapped on there in a different kind of way as to where they would have been if I don't need this anymore, as to those points that were there relative to their mapped points in the x and y. So you get these wonderful planes that you can start playing off of and moving according to how they're mapped. Now what I did was I took a vector, and I love this node system, this evaluate surface node, and it's probably worth going in and grabbing it and making a group and giving it a name. Now we did talk about the bifocals plugin, but that's on the other chapter, so I'm just going to go in here and I'm going to type evaluate surface, and it's a way to get around using the plugin bifocals. So evaluate surface is going to give me the points, it'll give me the normals to those points, it will give me the frames to those points, which you're seeing here, and it will give me the UV directions that I could end up using as a vector. Well, I'm just going in and grabbing the normal vector, which is at all those points what's coming off the surface, and I'm moving it in two ways. I'm moving that geometry in the positive and negative vector direction to the normal, which means these points end up going in one direction to the negative, and because I use the exact same remapping system on the other points, I can take those and push those in the other direction. So it's a kind of interesting thing to think what happens as I do that, and I build, of course, once again, that line in between them. So I have that control that I can then go in and pipe those things and come up with these curves. But if you're not following that, the script is there, it's available. It basically clusters in the use of curved closest points. It analyzes them on the surface like this, and then I'm remapping to the surface using a very strong algorithm, small algorithm of remapping domain and bounds, and then using one of the most powerful nodes for surfaces, which is evaluate surface, that gives you all of these. I wouldn't want to script evaluate surface in Python or C#. It's possible. It's just there's such a node that's so efficient here. Why not use that? And we'll get into that when we get into our chapter on hops. And those are those points directed by it. So when we go back in, these things controlling, pretty boring, is the I called it amplitude, but it's moving those points away from that surface. So if we look at that and consider that initial shift surface, then we've got the ability to pull those points in both directions away on both sides. I am curious. No, that's fine. They totally work according to the normal. And then I also have a means of I believe this is the diameter of the pipe, which we're not visualizing right now, and then I also can do an end cap that's round flat on those pipes. So those are just pretty boring parameters, but if we go back to the start of all of this and we consider what's driving that initial surface, and we start to turn that surface and twist it, you can see we have a really nice geometry that has to respond to that. And I think that's kind of the use of how parameters can drive one thing or the other. And of course I can build as much rungs as I want here. And sometimes I like to deal with lines and points and take off those last few sections of piping and just take that to disable, so we can go in and see all of our data as it's driven to what we selected, and we're able to go in and play with that. So I'm going to take this whole item here, I'm going to add it to my I'm probably going to add it to my shift this group, and we're going to call it group, and we're going to make it a blob, and we're going to turn it back into a beautiful color that I like to use for playground, which is a faded blue. So there's our faded blue colors as we select our geometries that we want, and we can go back to our initial script as we're trying to learn all of these functions as we make sense of the curve point object all the way down the foci. Which brings me to where I want to go next in the script, which I will do next Monday, because now I'm going to jump into learning Grasshopper through plugins on Wednesday at 9 p.m. and then I'm going to go in and show how to learn Python through using hops and Visual Script Studio on Friday. So we're going to continue with this, and there's a long script to go, and we're going to actually add to this with the functions to finish off curve, point objects, divide by curve, length of segments, and number of segments. And you'll find those right in the curve items under division, and we can start playing with all of these wonderful nodes to make sense of our script. I'm going to go over here, I'm going to leave on that little bit of blue, and then I'm going to play around here and just have fun with basically the rotation. Pi is just such a powerful tool to control this, but you can also play off of the heights of the Z heights of the y and really get some nice finesse on a -5 to 5 domain grid in the 3D grid in the X, Y, and Z directions. So really nice, and actually making use of the evaluate surface. I'm not sure if these parameters are doing anything. There's probably one other one, which is the focal points that I was driving the geometry. If I'm moving those focal points, I can have a major effect on that as well, affecting how those curves go as those points go in and out from where they were. And not so fancy, but nice enough. So nice little exercise to extend the workshop that we were working on to understand these functions, but the game is to really play with this, learn your functions, understand the data, and then get in here and make your own discoveries. Get in here and play and make your own discoveries with your own algorithms, and keep your files updated to be yours, and enjoy it. That's about it for tonight. I'm going to make it short. I didn't get it to this Monday night due to a hockey practice, but yeah, I'll try and stay on at 9. On Mondays, I'll probably go back to 7 p.m. All right. Thanks very much for watching. Michael at Wickerson Studios.